So I've got the enviable job of being between you guys and lunch. So I'm going to apologize to everybody in the room because I can talk quickly, but probably can't do it in 8 minutes. And those online, just go for it because it's like, you know, I'm starving too. So I'm here to talk about the work that I've been doing over the last 4 years, specifically in Northwest, but essentially setting up a project that we're looking to do around all of Queensland to build up a reference collection of mineral systems. My outline is essentially touching on the rationale that Vlad also mentioned in his last talk, focusing specifically on the samples and the data collection that we've done at GSQ in the ISG deposits in the Eastern Succession. And really, I'd like to just talk about the way forward, where we're going next with this project, and sort of some of the ideas about the next step filling in from looking at deposits into halos and into background, just like Vlad mentioned. So I looked at my first presentation I did in December 2018, and I was like, that's a bunch of words. So essentially the idea for this was to map mineral systems at all scales. So going from the macro to the micro and trying to understand the big systems. And what I realized was it was really ambitious. And also at that point, we had 3 people in our team. So we really couldn't do this alone. Secondly, Mount Isa province is really big. Even just the Eastern Mount Isa province is really big and really complex. So, but we decided there was a lot of benefit, a lot of previous work that had been done on the ICGs in that area from previous initiatives. So it was a good base to sort of start there. And also really, I didn't have any idea about how to map a mineral system. So the idea was to start with the known deposits, the known variations of these deposits, and work outwards. Which was tricky because when I started to look at our existing drill core collections that we had between the Mount Isa Library and the Brisbane Library, is that we only really had about 750 drill holes across the Northwest Queensland area. And when you look at them, only 160 of them had been drilled post 1995. And as you saw from the graph that Helen showed, that was really the sort of endpoint of a lot of the major discoveries. So what you were seeing was we weren't getting representative samples from those deposits, but equally the sort of core that we were getting afterwards was more reflective of greenfields, trying to find the next big one. Now we do have a really sweet collection of historical drilling that I think often gets overlooked from the shallow oxide deposits as well, and some of the first holes into some of these bigger deposits, which is very valuable. And that work has been, and that data and drill core has been included in the sort of things we've been doing. But what it left me was a lack of physical samples that were well located with context from major deposits. There's been a lot of really great work done over the years, specifically in PhDs, but where the accessibility to go back to those same samples might not exist. Those samples might not exist, the drill core might not exist, or the deposit might even be mined out. We didn't really have any samples or core from alteration halos of these deposits. But what we did have is a lot of really neat near-miss / greenfields drilling, as you can see, stepping out into the green undercover and sort of in between the major deposits. So we did have a good place to start. So what did we do? Well, we collected over 30 kilometres of new drill core, which is all publicly accessible, and it's representative drill core from these deposits. And I'll touch on in the next slide what I mean, what we've tried to do by getting representative drill core. We're able to build it up by having 150 additional samples, no, 1,500 additional samples. This was from drill core that we had access from companies where we were able to take physical material away and store that also in our library. So those same samples can then be come back to and have additional work done on it. We were lucky and were able to get access to company pulps, to crushings, even just pieces of drill core and samples from companies. And a lot of that is also still in our permanent collection. And really what this allows is value-adding research to continue on the same samples. And you'll hear about it in the after lunch sessions that a lot of the work that was done with codes and with CSIRO was the same exact drill cores, the same samples that we did multi-element geochemistry that we have high logger data for, and they've done more detailed work. So we can all be linked up to the same point in the same drill holes. There's a map, right? So what's representative drill core? Well, it's tricky because I wasn't exactly sure. Every deposit's different. Every deposit is different in size. And I guess I wasn't really prepared for just, what a high slog this was going to be, because it really was complicated. You had to get familiar with each and every deposit. The BRC deposit atlases were amazing because it was a really great starting point. So it involved lots and lots of discussions with companies, lots of me nagging. So I really appreciate everybody who was willing to, you know, jump in and get into these discussions. And we tried to get, you know, at least 2 drill holes through the guts of the ore body. So there's green ones over there. I don't know if you can see. Oh yeah, here you go. Yeah, anything in ore, we tried to get at least, you know, 2 to 3 drill holes that were representing the shallow to the deep parts of that system, and maybe the different variations if it was changing particular commodities at depth or there was zonation. If we could, we tried to chase the companies up to get drill core that we knew had previous work on it. So a lot of the Uncover Cloncurry drill holes, we tried to get that same one that had been sampled heavily by Cyro, or if we knew that there'd been work done on PhD projects and there was the capacity to get those same holes, we tried to do that as well. Like I said, the focus initially was for getting what the mineralization looked like, but when we had the opportunity, we started stepping out into the proximal and to the distal footprints. So some deposits like Ernest Henry, we had almost 20 drill holes that we looked at, you know, and some of the smaller deposits or the older deposits, you know, if we got 2 to 3 to 4 drill holes, we were really happy because we didn't have any data. I'm just gonna use my arrow. Nice. So that's the physical collection. So that's mostly up in Mount Isa. Currently there's some drill holes in Brisbane that are getting scanned, but the next aspect is the virtual collection. So what did we try to do? Well, we tried to be able to provide the data that you could look at before you even got to looking at the rocks in the core shed. We scanned pretty much the same amount of drill core with the high log of 3, specifically in the eastern succession. We had 5 kilometers of drill core from some of the same holes that we had high logged with core scan, which is, you know, a lot higher resolution detail. And then we also looked at getting about 4 kilometers of continuous XRF in 2 different stints between TrueScan and Mineralizer. And what that allowed us to do was to tie in our spot geochemistry, because we could only sample so much, we could only get through so much material and have continuous data throughout these deposits. And the destructive data acquisition really broke my heart sometimes because you knew that you didn't have a lot of material to work with. But essentially we had over 1,000 samples that we did multi-element geochemistry on. We tried to do and set a standard sample spacing that we have done for not only the deposits in the west, but over in northeast Queensland, which is roughly about 10 meters within ore, within mineralization, and sort of as you step out into alteration, about 20 to 25 meters. Now, this does vary if you're in sort of like sheeted veins in particular deposits where maybe you're not going to see, you know, as much alteration, but where possible within the deposit, we were consistent, and across the similar deposit types, we were consistent. And we collect a standard range of methods across all of the drill holes, irrespective of what the deposits are. So our aim is to have the same analytical methods that we do through ALS, which predominantly MS61 and MS81D, across all the deposits in Queensland to some degree. And then in particular areas, if we have questions, i.e. what's the germanium content in some of these deposits, or is fluorine or boron interesting in the fluids, we'll do additional analysis to answer key questions. But essentially the sort of work that we're doing is not at the micro scale. We're trying to understand the system. So we're looking at tens to 100 meter scale. So everything I'll be talking about next is what you can do with bulk geochemical and mineralogical drones. Glad touched on this. This is actually really neat. But what it shows you is that it's complicated. And honestly, I was kind of hoping having a lift suite geochemistry would be nice and everything would all match up and it would be easy. But as we've learned, Ernest Henry and E1 are pretty much just like themselves and like nothing else. And then you have these 2 slightly confusing groups in the bottom area, and I'll show you some examples this afternoon with the drill core that really are in the green and the blue, the groups. And what you see is that some deposits actually have parts that are in one and parts that are in other. So depending if it's a shallow representation or a deeper one, or depending on the sorts of the rocks. So it's quite interesting. But I like looking at rocks. So I tried to take those groups and split them up into the main sorts of proximal and ore alteration that you see. So obviously you can see number 1 is the Ernest Henry style, and predominantly it's, you know, the rocks have been strongly K feldspar, altered and magnetite altered, and then obviously brecciated. Now, Little Eva and Swan have aspects of both the albite with hematite dusting and magnetite and group 3. But you can see it's complicated. and also Ernest Henry, very close to Ernest Henry, just above and below the ore body at depth, you actually see actinolite, calcite, and magnetite with chalcopyrite. And these sulfides have a very similar signature to what you're seeing in the main ore body. So they're related. I'm not going to get into timing because we haven't got there yet, but I don't know exactly time-wise, but it's really interesting to see just, I mean, I expected everything was going to be full of red rocks, yeah, and they're not. Everything seems to be green. The more and more I go, more things are looking like the blue group that Vlad showed and the green group, so Ernest Henry, Eloise, and Swan. So some of the power of the high logger data, and I'm not sure, you know, who in the room really uses this, but it's just this very simple, essentially stuff that is done by our spectral geologists. So we've got Siraj here today. I'm just looking at major mineral groups and major minerals just downhole. So this is a drill hole that is in Ernest Henry. I haven't marked ore because my animations are being jerked, but essentially the shallow part of this drill hole here is where the ore is. So this is a shallow hole from Ernest Henry that hits ore in the breccia pipe, and then it goes out of the ore body. And as you can see, you have, and you don't need to see the different groups, but essentially in here, you've got combinations of albite and different plagioclases, K feldspar. There's some variations between autoclase and microcline. You can see beneath the, wait, no one can see because I'm not pointing. You can see that there's carbonate above, wait, no, it wasn't mouse good, above and also below the ore body. And you can see there's different compositional things with chlorite happening. Looking at something that we just saw in Vlad's geochemical plot that is so different, as this is a drill hole that we're going to be looking at this afternoon, that's through Eloise. So this is through the Eloise deep part of the deposit. So it's quite deep at the moment. And that is, you know, ISCG. It was in the blue group with a different geochemical signature. But one thing I've noticed that just staring at these things for a very long time, that the proximal alteration is very similar. You're seeing the same plagioclase, the same feldspar, K feldspar alteration. So the top of this hole is ore and the bottom of the hole is out of ore. So as you see it zoning, there's K feldspar alteration. You're seeing the same magnetite. Wait, no, you're not. You know, if you can't see my mouse, but down the bottom, you can see we pull out magnetite, we can pull out iron oxide. You're seeing the same carbonate, the same chlorites, the same micas, and the same actinolites. So actually the proximal alteration close to Ernest Henry, maybe the intensity of your K feldspar is different in these systems, but actually it's popping up a bit. So it's really interesting to see that you can glean a lot from this sort of like coarse data sets. And then you can go in and start testing, you know, what particular phase of that, you know, carbonate is it, what sort of K feldspar are you looking at with detailed work. But just looking at a whole, you're realizing that actually things are kind of, you know, quite similar. So I'll have a quick talk through the Ernest Henry camp, just because it's been really great. We have a ton of samples, but it's not that it's Ernest Henry, it's an illustration of the sort of thing that we want to start doing at different deposits. So yeah, this is an old slide that says it's a typical iron oxide copper gold deposit. Yeah, not really, it's the only one of its kind. And it's magnetite dominated end member. With this study, we wanted to see how far away we can see the signature. So that box there is about 6 kilometers in scale. It goes out of the Ernest Henry deposit up to a similar but smaller magnetic sort of anomaly, which was the FC4S prospect. We sampled a lot. We sampled 460 samples from over 11 kilometers of drill core just from Ernest Henry and MMAs. We also managed to have 9 of these drill holes that are in our permanent collection. So, and all the samples as well that are collected from the other drill holes are available. And that'll be also out this afternoon. We'll have some sub-sample drill holes laid out so you can sort of see what happened, what EH147 looks like. So about 1.5 kilometers away, what the signature looks like. We've done a bit of continuous XRF scanning and we sent over 230 samples off the multi-element geochemistry. And this is just where the next slide is going to look. A slightly different view of Vlad's, but this is looking from Ernest Henry and stepping away out to MMA2. So one of the big things that I really wanted to see how far I could push the high logger and how much I could help problems I was having just looking in the field was that, you know, feldspar alteration is hard. It's confusing. It all looks the same. And is there a better way to pull apart not only the different minerals, but the different generations of the same minerals? We're finding that in a lot of this system, there's more than one albite. There's possibly slightly early. There's also ore-related albite. Similar with K feldspar, there seems to be orthoclase dominated within the guts of the ore body, and sort of in that sort of proximal area, high logger is identifying this to be microcline. And when you look at the rocks, I mean, there's obviously the too far photos are very obviously potassic alteration and sodic alteration, but you know, I wouldn't pick this as being potassic altered, and I wouldn't pick this as being potassic altered here. So, and in this one here, which is slightly red, is also albite. So what I did was I chucked a whole bunch of drill holes throughout the deposit on a section and just started to see what general trends I can pull out. Something they can see is that you lose albite. So my arrows are the other way. I'm talking about it going from background to ore, but my arrows go from ore to background. So just don't mind me. Albite decreases towards the ore body. You lose that regional widespread alteration. Not so sure about that yet. And you're seeing it overprinted by biotite and biotite magnetite. And the biotites are changing composition. So some of the really neat things I've seen so far, and we've got in the high logger data, is that, you know, your biotites are becoming more iron rich, your chlorites are becoming more iron rich, particular minerals are changing depending on what generations they are. And then you can start to identify this with your eyes and realize this is the right biotite magnetite, this is the right albite. Obviously, you have an increase in K feldspar from the MMA holes to the right as you go towards the ore body. Predominantly, most of this fine grain weakly pervasive alteration is picked up by high logger as microcline. And then you see a slightly different orange that's in the guts of the ore body, and that's coming up as orthoclase. So high logger is definitely saying that there's two different K feldspars. Looking at the SWIR, so that was looking at the, I didn't mention at the thermal, this is seeing what else you can pull out of high logger, just putting the summary screens next to each other on a section. I'm pretty sure that's Fe-rich chlorite composition increasing towards ore. It goes from magnesium rich all the way to the right, which is predominantly just in the rocks, to iron rich in this proximal and distal. And then in the ore body, it's a bit varied. So you do see predominantly a combination of iron and magnesium rich, depending on exactly what bit of the rock you're in. There's a decrease in just generally in the amphibole group, which is that nice purple color that you can see. So the hornblende, which you can see in MMA, is reflecting the host lithology. One thing that we've seen, and when we looked at Ernest Henry, it was very confusing, is that there's a lot of actinolite, and actinolite is in that proximal alteration halo, and that actinolite comes with magnetite and it comes with chalcopyrite. So there's, you know, and calcite and a whole bunch of apatite. So you're seeing that predominantly almost as a vector in that distal to proximal area. And there's an increasing carbonate calcite towards the ore body, and specifically above and below the ore. So this is something that's been quite known. A lot of these observations were done from Geordie Mark's work, which is a PhD, where they looked at many samples and did a ton of really great work. And we've been able to then confirm that in bigger, bulker, sort of broader geochemistry and mineralogy. And this is a really neat picture. Vlad touched on it. Essentially, this is what we've been able to do. So this is only looking at copper size. So the big dots mean it's got most of the copper. And what you're seeing is that within the ore body, everything's red, and that's reflective of the K feldspar, the typical Ernest Henry signature. But every now and again, you're seeing these orange ones that are plotting, and they have high chalcopyrite, but they're not sitting with K feldspar, or they're not sitting with the traditional alteration. In this sort of 2 to 3 kilometer area here, biotite and magnetite is important. It's a related halo of the deposit. It's often been mentioned that you have albite and you have biotite magnetite. That might be early and unrelated, but there's distinct zoning in your biotite composition, also in the chlorites, that you can see exactly how far you are away. So it's really neat, but this is just the start. We're really hoping to do this for a lot of different deposits going forward, not only in the Northwest, but in Northeast, which is a nice way to go about the way forward. I'm just going to sneak this in. Essentially, we've started a new funding package. It's New Economy Minerals. There's a little bit more work to do in the Eastern succession. So we had a glaring gap in not having anything from Rocklands. So trying to fit that in there and see how it fits in the 3 groups will be really interesting. We're missing a lot of the smaller deposits and the smaller prospects, really trying to capture the system. Some of the things that Ken were talking about, that whole family and group of deposits sort of south of Cloncurry, we're going to go and try and build up the same data. And one of the focuses is really to try and constrain the timing, because I think it's important, and I think the existing data that's out there is great, but the context behind all the dates and all the samples might be lacking. So we're going to try and, tidy that up a little bit. Equally, Eastern succession work isn't the only thing we're doing. We have the rest of the Western succession, not only copper, but lead zinc that's wrapping up. So we are still collecting our geochemistry and our high logger data here. We were really lucky. Couldn't find a love heart emoji symbol, but to get 17 drill holes through Mount Isa, lead, zinc and copper that are currently now in our permanent collection, and they're beautiful and it makes me really happy. But equally, we're getting samples from Century. We're working all the way from Capricorn to Mount Oxide to Mount Kelly. So we're filling in essentially the gap from Isa, up to Walford Creek in the major deposits. But also at the same time, I have a project that's 1 year in, looking at characterising Northeast Queensland deposits. Same logic, going to the major deposits, collecting, representative drill core, high logger data, geochemistry. And in the first year of the project, which ends mid next year, we're looking at the Herberton region. And this will be the first time we're looking at, yes, the major deposits, but we're going to actually try and map out the mineral system, because it's a region. There's zoning across the area, and there's zoning within each deposit at depth. So just trying to build on that really great work that was done in the 70s, but with more modern data is something really interesting. And now with that modern data, we can equally then start understanding where the critical mineral endowment is, because it's obviously new economy minerals, and we all know we know this stuff is there, but it was never assayed for, or was just a comment from a miner back in the 50s and 60s that it existed. A really good start was that we recently just acquired 190 new drill holes from this area. So we actually have the coverage of the whole Herberton region, essentially all the different variations. So it's a really great place to start collecting this data. And we're also working with JCU and also in UQ, not only in deposits, but looking at comparing the tailings. So I'm going to stop in a minute because I'm hungry, but essentially I've been hungry for like hours. How do we go beyond deposit footprints? And really, I just wanted to put these things out. I'd love you all. I'm going to hit you up for that link that Helen talked about, and Rick, I'd love to know. I know a lot of these data sets have only recently been uploaded to the portal. So I'd love people who've had a look at them, or, have come back, have a look at them and then come back to us in emails and just let us know. I'd love to fill the gaps between the proximal and distal alteration and start moving into background. So for those who don't know, we have a regional prospectivity project that's happening, and I'm really hoping that that is going to be the mechanism to start collecting the data, the same geochemical data, the same analysis, the same sorts of things we're doing now to define where distal and then what background actually is, because if you don't have background, how do you know what you're in? And then just flagging ideas about continuation of things like trace element geochemistry, mapping the isotopic signatures of the alterations, some of that really nice stuff that Joe mentioned about the stable isotopes as well. I feel like that's excellent, specifically in the Western succession. So, love to hear your feedback about this sort of work. And my summary, hey, we got a lot of rock. We don't have enough. I'm still trying to build it up. We're collecting systematic continuous data where we can for mineralogy and spot geochemistry to tie it in. Trying to create the link, trying to help. The whole aim of this is to trying to help you guys exploring, where you just drilling drill holes on particular geophysical targets or things you've done in an area, understand what you're seeing. And I didn't know what that was because I didn't actually understand what the key minerals and the key phases were until I started, and I'm just starting to get there. And I just would acknowledge the team. The team is a lot bigger than it is. Honestly, wouldn't get anything done without everybody, so I'm appreciative. And also every company, thank you to everybody who's chatted, everybody who's shared samples, ideas. It's really great. And if you've got any drill core just lying around that you'd like to offer me, you know where I am. You see me at the call shed this afternoon. So thank you.